Yep.
All right, good. Check yourself if you're still trying to work to get your notes out. You've got left 1 minute to get started on one of these problems. That means not starting, I haven't written anything yet, like I've solved A, or the first one, and I'm moving on to another one. Seconds. All right. Israel, Felix, Edith, Eli, Dahlia, Stephanie, Diego, Jamie Lynn, Sandy, Brandon, Brian, Juan Carlos, Martin, Nen, Kennedy, Giselle, Leo, Gustavo, Lirio, Tyler, Melanie, Lazaro, Jonathan, Messiah, thank you, Joanna, Kevin, Eham, Christina, Johnny, Luis, Deanthea, Brian. Cool. All right, that's your time. So I'm gonna walk around, make sure I got everyone started good at this table. I've got 1, 2, 3, 4 people started. 1, 2, 3, 4, 5. All of them started here as well. 1, 2. Started yet? Not quite. Get going. 3 out of 4 started here. 1, 2, 3, 4. Everyone here. Woo, woo, woo. 1, 2, 3, 4, 5. Good. Everyone started here. Nice. I don't know if they're all right, but at least everyone put forth some effort on these, which I love to see. We're going to go ahead and get started. Okay. Let's talk. Okay, happy Monday. How was our weekend? Anyone see that game last night? Anyone tired because they stayed up? Anyone see the Dynamo game?
Today.
There's another one today.
What do they even play?
Tomorrow.
Dynamo. What are they?
This one today?
Today.
Dynamo plays today.
For Dynamo? So Dynamo's plays today. Oh, we switched. Great. So Dynamo plays tonight. Then we got more baseball tomorrow. There's a lot of things
Rockets
going
today
on.
also.
If you're a sports person, a Houston sports person, then it was a big weekend. Except for if you're a Texans fan, then it was a sad weekend. They lost. Rough. Anyways, and if you're not into sports, you're like, I don't know what's going on. But that's okay too. Okay. In the pre-cal world, Voices Up Eyes Up here, it's also a big week because we are continuing with logs and exponential things going on. And we have our first quiz on Wednesday for you guys to show me what you know. So hopefully this due first was kind of an indication for you of when you saw a log after the weekend and after it's been a few days. Did it look like some crazy foreign language that you had no idea what log 2 of 8 meant? Or did it come back to us kind of quickly? Because we want to be really familiar with these as we move towards our quiz. Because now we're taking logs. Today we're going to step it up a notch. We're going to learn some more properties. Or we're really going to be able to start manipulating logs even more. Okay? These ones should have, like, when it says evaluate, like a value, like a number that these are equal to. The log should go away. This is equal to a number. Today we're going to be getting other log expressions that are equivalent. So really start differentiating in your mind the difference between the different directions of what they're looking for in your answer. If we say evaluate, we want you to literally solve for what it's equal to. Okay, we also have our last week of A2, so that means you're going to be turning in your participation trackers Thursday or Friday. I haven't kind of decided yet, but either way, make sure you're getting lots of stamps. So let's start off with the first one. Who's got log base 2 of 8? Jonathan. 3. Log base 2 of 8, 2 to the 3rd power is 8, okay? Next one, let's go this way. Log base 2 of 2 to the third power, Edith? 3. Remember we said there's either a property, you can think of the property that says that those cancel if they're the same, or 2 to what power is 2 to the third power, and you'd have to say 3. You can either like go back and write it, or just think of the property. Okay, Brandon, next one, what about this one?
Negative 14.
Negative 14, same thing. When we have ln and e, that's like having log base e of e to the negative 14. These would cancel. ln stands for log base e. And Sandy, the last one. 2. I've had today a couple 10s. Anyone in here think is 10? Okay, so you were thinking 10 times 10 is 100. But what does that mean? 10 to what power is 100? 10 squared. Okay? So that one would be 2. And if y'all, after we say one of the answers, if we could limit just the side comments and stuff, then we can move a little quicker, get some more practice, okay? So those are evaluating logs. You will have that as well as graphs and all the things we learned last week and a little bit of what we are going to learn today on your quiz on Wednesday. There is a lot of practice on your problem set that you just got out of the blue folder that reviews all of those things, in addition to a section on expanding and condensing, which we're going to do today and tomorrow. So if you felt like on that do first, man, I wish there were a few more of those that I could practice for Wednesday. The first like 6 problems on your problem set this week are those types of things, okay? Make sure you're not working on it now in class. I will be taking up any problem sets I find y'all working on. All I should see you working on is our stuff right now. Cool? Okay. A few other cases of this that I want to recap really quickly. If I were to change this first one, just a small change to not 8, but 1/8, can someone remind me how that would change my answer? It wouldn't be 3, there it would be what? Negative 3. 2 cubed is 8, but if it was negative, it would send it to the bottom and we'd have 1/8, okay? Another thing we talked about last week that might be a little foggy, if I said log base 2 of the cube root of 2, I would say 2 to what power is equal to the cube root of 2? Does anyone remember how I can rewrite a root or a cube root or a fourth root or anything like that? Ehon?
1/3.
Remember, any roots, we're going to use this again today, can be written as a fraction exponent, like that. That's the same thing, that's equivalent. And so this would have to be equal to 1/3, okay? So be familiar with negative exponents, be familiar with roots or fraction exponents, all of those things we could ask about. Yep?
So the exponent inside of the root would be the denominator in the, like if you were to
Yeah.
write as a fraction.
It's called like, I think it's called like the index, not the exponent in the root, but this little number right here tells us like the square root of the cube root, and that's the denominator of your
No,
fraction.
and the one inside of the.
Oh, this right here is your
It would be
base.
2 squared, like let's say it would be 2
If it was the square root of 2,
So like inside of the root, you have 2, what if, can it be 2 squared?
and then a square root,
Yeah.
those would cancel because the square root of something
It should be
squared
2.
would just be 2. So then this would be 1. Right? No? Yeah, I like it. The what if game. What if this? Okay, cool. Properties of logarithms today. Today we get to learn 3 new properties of logarithms, things that you can do with logarithms, make them go back and forth and find equivalent forms and all that. And then we're going to be using them to do a couple new things with logs, like write a log in terms of other logs, or to expand or condense a log. Okay, so let's go ahead in this blank space right here. I'm going to have y'all write down the 3 properties we're going to learn. I'm telling you right now that there's 3 because you kind of need to know how to split up this space. And in the last class, I had some people that like on the first property, when I went on to the next one, they were like, wait, there's more? I used literally all of the space for the first one. So just so you know, there's 3 coming your way. First one is the product property. The product property states that log base b of x times y equals log base b of x plus log base b of y. Okay, so let's kind of break that down. Product property has to do, it's called that because product means what? Add, subtract, multiply, or divide? Multiply. So we're talking about when we are multiplying two numbers. So in that case, if I had x, y, that means x times y. So we're multiplying x and y. I can basically rewrite a log of a product as separate logs added together. Right? I broke it up into a log base b of x and a log base b of y, and then I added those two logs together. Should be equivalent to the same thing right there. Okay, let me show you an example to kind of prove this with some numbers. Let's take the one we did in our do first, log base 2 of 8. We said that's equal to what? 3. Okay, so let's really quick make sure that if I break it up like this, I still get 3 on both sides, okay? I could rewrite log base 2 of 8 as log base 2 of 2 times 4. Do you agree? 2 times 4 is 8? Okay, and since these are being multiplied, it's a product, I can split it into 2 log base 2's, one that has 2 and one of them that has the 4. Let's check, because this is a property, let's check and make sure that both of these are equal to 3, okay? We said that log base 2 of 8 is 3. Let's check this one. Raise your hand if you can tell me, just practicing again, evaluating logs. Log base 2 of 2, raise your hand, would be what? 2 to the what power is 2? Raise your hand. 2 to the what power is 2? Kevin?
1.
1, okay. Plus, next one, log base 2 of 4, 2 to what power is 4? 2 to what power is 4, Diego? 2. And then let's check. Is this side still equal to 3?
Yes.
Yeah, so that's just showing you that you can break up a log into 2 separate logs using multiplication. You can break it into 2 logs being added, okay? Now, why is this helpful? In general, it's nice and important for a lot of skills that we're going to learn today to be able to go between different forms of logs, right? So maybe there's a reason that I want these logs to have smaller numbers in here. Maybe I want a log of 4, something like that. So it's good to be able to go back and forth between different forms. Okay, next up. That's the first one. Next up is the quotient property. Let me scoot this up a little so you can see. Okay, the quotient property states that log base b of x divided by y, quotient means divide. If I divide x and y, then that's the same thing as taking log base b of x, log base b of y, and not adding but doing what? Subtracting. Notice there's a subtraction sign between them. So a quotient I can separate again and have 2 separate logs subtracted, and that will be equal to the 1 log with the 2 numbers that are multiplied together. Divided. Division relates to subtraction. Okay, I'm going to use the same log base 2 of 8 to kind of show how this is true. I'm going to rewrite log base 2 of 8 with division as 16 divided by 2. That's still equal to 8, right?
Yes.
Okay. That means that log base 2 of 16 minus log base 2 of what? 2. The thing on the bottom should still be equal to 3. Let's check. This is 3 equals, raise your hand if you can tell me, log base 2 of 16, 2 to what power would give me 16?
4.
2 to the 4th power, so this is 4, minus log base 2 of 2. We actually already did that in the first one. That was 2 to the 1st power is 2, right? Does it work? 4 minus 1 is 3 as well, right? Okay, so division we could rewrite as subtraction. Last property, the power property. Is it okay if I erase this 3 equals 4 minus 1 because I'm running out of space? Okay. Okay. The power property doesn't have to do with multiplication, product, or division, quotient. It has to do with when I have a number raised to a power. So I'm going to use P to represent the little exponent or the power. This property says that if that's true, then I can move the power, the p-value in front, multiplied times the log, and I should get the same answer. So we're going to get really used to just moving exponents out of the way, being multiplied out front, to be able to solve something. So let's use the same example. If I have log base 2 of, if I want to write 8 with a power, I could write it as 2 cubed, right? That's still 8. That should be the same thing as moving this 3 in front and saying 3 times log base 2 of 2. See how the 3, the little exponent, is now in front. And this is 3, so let's check and make sure this is 3. 3 times, one more time, 2 to what power is 2?
1.
Is 3 times 1 equal to 3?
Yes.
Nice. Logs are so cool. Like, even back to this first one, you need someone? Go ahead. Joanna. Even back to this first one, take a look. We didn't, when we did this morning, we just thought of, or not this morning, whatever, the do first, just so long ago. 2 to what power is 8? We said 3, right? If you rewrite it like this is kind of cool. What did we say happens with the log base 2 and the 2?
They cancel.
And it's equal to 3. That would have been another way you could have solved that. So there's lots of ways you can kind of go back and forth between all these log properties and solve these types of things, okay? Cool? Okay, so this is an example of the 3 properties. We're going to be using them today to do a couple of things. First task we're going to do is I'm going to ask you to rewrite a log like the next one we're going to do. You're going to look at their work, log 54. I'm going to ask you, this is log base E, so ln of 54. I'm going to ask you to rewrite that in terms of ln of 2 and ln of 3. Maybe for some reason I want this in terms of ln of 2s, like a smaller number in here. If I want you to rewrite this in terms of ln of 2 and ln of 3, this person has already done the work for you. I want you to follow their steps. We're going to see what they did. Okay? This example right here, we have ln of 9/8 to start off with. Same thing. I tell this person, I want it in terms of ln of 2 and ln of 3. It's kind of like if I have a fraction and I tell you, I want it to still be 1/2, but I want it to be in terms of eighths, right? And you would say this is the same thing as 4/8. So you're just finding an equivalent form that looks different, okay? So what I want y'all to do, yours has a little 1, 2, 3 right here, right? I want you to take a second. I'm going to give you about 2 minutes, about a minute for each, to write down in the spot 1, 2, and 3 just your own description of what the person did. I want you to see if you can follow their work to see how they rewrote it in terms of ln of 2 and ln of 3, and then we're coming back and share out and do our own version on another problem. But I want you to analyze their work first to see what they did, okay? 2 minutes, go ahead and take a look at these, see how they broke it up, how in the world did they make ln of 54 into ln of 2 and ln of 3. Talk to each other, write down what you noticed. Right. On this first line, they just rewrote 54. It's kind of hard to tell right here, but 3 to the power of 3 would be 3 times 3 times 3, so that's 27. They just rewrote it as 2 times 27 is 54, so they just rewrote it. They like factored it basically, and rewrote it as 2 times 3 cubed, okay? The reason they did that is because, like I said, we wanted in terms of ln of 2 and 3, so they were looking to have 2's and 3's, and so they factored it into a bunch of 2's and 3's. Okay, now from this step to this step, what do you notice changed? They separated it from this multiplication to what? 2 different ln's with a what sign in the middle? Addition. So which of these properties was that? Product property. So this step, they did the product property. Okay. Interesting. Next one. From here to here, what do you notice changed?
3 cubed
What, where?
to the outside.
Out front. And what property is that?
That's the power.
So then they finally finished, so that they got a ln of 3 and not a ln of 3 cubed. They used the power property on that last step to do that. So they like factored it, split it up, then they used product properties, and then they used the power property. Okay? Go ahead and try to do the same thing, see what they did there, okay? About 10 more seconds. Minute save. Good? Good? Okay. Okay, for the first one, I'm just going to kind of review what Brian and I talked about because we were up here working on it. And then for the second one, I'll take a volunteer to kind of share out what they got. And then when I get you all to practice in a second, I'm going to come around and get stamps to anyone I owe or anyone that's been answering questions. Okay, so for this first one, we noticed I should probably add this. We saw that they just rewrote the 54. They basically just use factors to rewrite 54 as when we were trying to write it in terms of 2s and 3s. They thought like, okay, if I take 54 and I divide it by 2, that's 2 times 27. And then I could write 27 as 3 cubes, right? So they just broke it up into some smaller pieces. Then they used the product property to separate that multiplication into addition. And then they used the power property to move that little exponent of a 3 in front. Okay? Okay, someone else, can you help me explain what happened on this other side right here? What properties you see or what they did in this line? D'Anthea, go for it.
The first step, they did the quotient property.
Okay. They split it into subtraction by the quotient property. What did they do next, D'Anthea?
Factor.
Yeah, they kind of just rewrote 9 with like exponents, and they rewrote 9 as 3 squared and 8 as 2 cubed because again they were trying to get to 2 and 3, so they needed to split that up. Okay. And then last up, what did they do?
They did the power property.
Power property, and they brought the 2 in front and the 3 in front. Okay? So I didn't write all that down, but D'Anthea said it. You can write down any of those properties as you go. Okay, so your task, you don't have to label everything, but I want you to think through which properties you're using. Your task now is to kind of like use these as an example if you need to flip back to them. But go ahead and take a look at this check for understanding here at the bottom, where I want you to rewrite log 75. I want you to make the 75 like go away. I want your answer to still be equivalent, but I want it to be in terms of log 3 and log 5. So again, start thinking about some factors. How could I rewrite 75 as something times something that involves 3s and 5s rather than just 75? Okay? Try that out, see if you and your neighbors can rewrite that one. And then I'm going to come around and give stamps while we wait. Does anyone have stamps here?
Remember stamps? I mean, the tickets for this thing?
You know where I put this one?
I think so.
So I'm not worried as much as like which number 1, number 2, number 3 is which, but from here to here, what changed? In your own words, what changed about in front, which is the power property? Yeah, she was just saying from here to here, they took multiplication and they rewrote it as addition, which the product property tells us that you can rewrite multiplication as addition.
Oh, I did it.
More stamps here. Stamps.
Follow the same process. Yeah.
Another one. Okay, so let's think 75. I could rewrite as quotient what? I'm trying to get 3 and 5. Can you do 3 times anything? Yeah, because 3 times 25, right? 3 quarters would be 75 cents, right? So 3 times 25. But then, like you said, I could write 25 as 5 to the power of 2. Right? So let's rewrite this as log 75. Let's rewrite it as log of 3 times 25. And then she says, now let's write this as log 3 times 5 squared. So that's 25, right? Okay. Now if this is multiplication, like this, x times y, how can I split it apart?
Yeah, because I'm trying to like resist it, but I can't.
Log 3 plus log 5 squared. And then last step, work in this little 2x multiplier.
Did I do this right?
And parentheses at a time. Okay. Alright, so let's take a look, see what we came up with. Nice, you just lost your, so these are not LNs, right? We start with an LN. So we need to match, this is like a base of 10, so we want all this to have a base of 10. Okay? When you have this right here, since this is multiplication, we can split it like this into a log 3 plus a log of 5 squared. And then last step, we're going to do that too. Couldn't we do with exponents or powers? Okay. Alright, y'all. So first set of instructions. Using our 3 properties, one thing I could ask you to do, which we're not going to do much more practice with this, but I want you to use this example whenever I ask you to rewrite a log in terms of other logs. I'm saying, like, use your properties to start factoring this and, like, breaking it down. And in this case, I did 75 is 3 times 25. And then I split that into addition. And then I rewrote 25 as 5 squared. And I moved that little power in front. My final answer was log 3 plus 2 log 5. Melanie? You should, like, okay, so here's my, like, philosophy of this. When you're memorizing it, like, all I want you to do is understand these properties. And so that does not mean that, like, right here I'm memorizing that a log with a b with an x times a y is a log with a b with an x plus, like, don't just memorize the symbols. Memorize the fact that multiplication is addition, division is subtraction, and a power it's going to move in front, right? And then you should be able to write these with any problem. You're not going to have to write them with x's and y's, right? And, like, I don't think it's a good use of your time to memorize them and on a test, like, write them down on the top. Like, you're going to use them so much. And Melanie, if you're doing, like, all the practice on your problem sets and the practice you should be doing at home, then these should become rules that you just know that you memorize as you practice them, because we're going to use them so much. Okay? Cool. All right. Any questions about where this came from? I can kind of pop in. If anyone didn't get to that, I'd love to talk to you, but I'm going to keep us moving so that I don't have to go through every problem that we solve. Okay. Next set of instructions. I could also have you use the properties not to rewrite something in terms of other logs, but just to rewrite a log, either what we call expanded or condensed. So we're going to start with talking about expanding. We're going to kind of close class with talking about condensing, and we might not get through much of condensing. But then tomorrow is like a practice day with all this, so I can wrap up anything we miss, and then we'll practice it, okay? So let's talk about expanding first. Notice, this is one log, right? A log of like a bunch of stuff, okay? What do you think? Let's again practice like looking at your directions and thinking about what you're probably going to be doing. What does it mean just in general in English if we take something and expand it? Raise your hand if you can tell me what you're thinking of when I say to expand something. Melanie?
Simplify. No.
Just don't overthink. I'm not saying math. Like, what does it mean if I expand
Make
something? Yeah, make more, bigger. Like it should just be growing, right? Okay. If something's expanding, it's growing. Like if you take a marshmallow and you put it in a microwave, Anyone done that before?
Yes.
You should try it. It gets really big, it
Oh.
expands. So, we're gonna be taking our log and we're going to be expanding it using our properties to change it from just one log to we want to break it into a lot of logs and so it's expanded, it's bigger, okay? So looking at this first one, we have the log of 12 x to the 5th y to the negative 2. When I look at this 12 x to the 5th y to the negative 2, what operation, add, subtract, multiply, divide, do I have if they're like right next to each other like this? Raise your hand if you can tell me, am I adding these two or multiplying or subtracting if they're right next to each other like that? What am I doing? Dahlia? This is 12 times x to the 5th times y to the negative 2, right? So those are three separate things being multiplied. When I think multiplication, and I'm thinking about the properties we just learned, that was the product property. Melanie says multiplication, I can change to what? Addition, right? So now I'm just thinking, I don't really have it like memorized, I just have that I know those two are related. So I can take this log and write a bunch of logs, 3 of them, right? With the separate pieces. So I have log base, what base is there if there's not a base? 10. And so if this had a number, I'd need to write the base every time. But right now it's log base 10, so I don't have a base of 12. Log base 10 of 12. Plus Melanie says I'm going to do addition because it was multiplication. Log base 10 of, what's the next thing?
X to the 5th power.
X to the 5th power. Plus log base 10 of y to the negative 2 power. Okay, so we're a little closer. It's definitely expanded already. It's bigger already. But we want to expand it as much as possible, use the properties until there's nothing I have left to do. So when I look at these two, let's actually start with these two. When I look at these two, looking at your properties from above, which one could we use to kind of keep going and do something else with these two right here? So everyone, I should see some more hands. Look back at your properties. Which property could I use to do something with log x to the 5th, log y to the negative 2? Felix, which one do you think? Power property, I can bring them like in front. So I'm going to come back to this log 12. Leave a space really quickly. While we're on it, let's say 5 log x, and then a minus 2 in front would be a minus 2 log of y. Okay, let's talk about this one. I can't bring an exponent out front because there's no exponent, but just like I did with the 75, as an example ago, I split 75 into 25 times 3, right? Jamie, can you think of anything? 12, what times what gives me 12? Yep, 3 times.
4.
Good, perfect. Got it. 3 times 4, right? Okay. Now that I have this as 3 times 4, because that's multiplication, one more time, I'm thinking multiplication product, one more time, I know that every time multiplication can be split into addition. I see Millie going, she's already got it memorized. So we're coming up here. We're going to say log base 10 of 3 plus log base 10 of 4. I just split those two up, right?
Yeah.
Plus 5 log x minus 2 log y. I'm writing everything out. It's expanding. It's getting bigger. It's getting bigger. It's getting bigger. Okay. Let's check and see if we can do anything else. From the back. This guy I think is done. I can't do anything with y, right? And the 2's already in front. This guy I think is done. I can't do anything with x. This guy, can I do anything with 4?
Yeah.
What can I do, Christina? Yeah, so like in one step, I'll kind of like show everyone. She said 4 is 2 squared, right? 2 squared, and then the 2 can go in front, so that's why she said 2 log 2. But I'll write it down as 2 so that y'all have it in your notes. If you can do that in one step, that's fine. If you want to see all of the steps so that you have them in your notes and can see where everything came from, this now is the exponent goes in front. 2 log 2. Nearly done. Oh my god. Woo. Okay.
Whoa.
Expanded.
That's in the back.
Okay? Okay, we're going to do one more with division together, and then y'all are going to practice 2 of these, looking at the examples we did.
Okay, that's so much.
Okay, next one. Next one, Diego. If I have an ln right here, Diego, if I have an ln right here, that's a base of what? E. Good. So that means all of my answers, like this, they all say log, 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 because I started with log. And this one, when I separate it, they should all be ln, right? Later, when we get to the bottom, all of your things should be log 13, log 13, log 13 of whatever you have inside, okay? So let's take a look at ln, and then we'll move on. So ln, I've got x squared divided by the square root of 4x plus 1. When I see division like this, I'm thinking quotient property goes with subtraction. So ln of x squared, the thing on the top. Division means, one more time, division means, everyone? Subtracting ln of the square root of 4x plus 1. So this is the top, this is the bottom. I'm no longer writing it as division, I'm writing it as subtraction. Okay. Looking at the first one. Kevin, looking at this, what could I do to keep going with this part of it? Yeah, what would I move? Yeah, what number?
2.
The 2, the power, is, we could write this as 2 ln of x. Happy? Okay. Minus, for this one, notice in the do first I talked about how we can rewrite roots in another way. The square root I could rewrite, because I want to deal with like powers, as what, Diego? 1/2. So this is 4x plus 1 raised to the 1/2 power, right? That's the same thing, 1/2 power. Why do you think, raise your hand if you can tell me why I would rather write it as a 1/2 power than leave it like a little square root? How does this help me to keep going? Christina? Once I have a power property, I can move it in front, right? So the reason I did that is so that I would have a power to move in front. Melanie, question? This part?
No.
Back to the other one? Okay. Yep, Anthea?
Are you gonna break down the floor?
Well, let's talk about it. One sec. 2 ln of x. Let me catch up here. Great. I'm running out of space. Okay, now you probably noticed I put parentheses around this 4x plus 1 when I wrote it with ln, because it gets kind of confusing if you just leave it like this. I don't know whether it's ln of 4x and then like a plus 1 whole 1 on the outside, or if I want ln of the 4x plus 1 where the 1's included on the inside. Because it was underneath, right, it was in the ln, I still want it to be in the ln like this. Okay. Now this tends to get some people, because people feel like since we're breaking everything apart, that I should be able to break this apart, right? But we do not have a property that says that we can take 1 ln or 1 log with addition and break that into like addition. So this is stuck because there's no way that we can break apart addition. I can take multiplication and break it into addition, but I can't start with addition and break it into anything.
Okay.
So this one is stuck.
Okay.
There's nothing else we can do. Final answer like this. So when you have an expression being added like that, you gotta leave it. You can't break it apart. Okay. So here's what I want from y'all. The next 2 problems, notice, are not these ones. The next 2 problems are on condensing, which we're going to come back to. First, I want you to practice these 2 problems, which are very similar. The top one's very similar to our top one. The bottom one's very similar to our bottom one, so you can use them and try it out on your own. Then we're going to come back and see if we can get started on condensing before tomorrow if we have enough time. So you are on the 2 problems down at the bottom. Everyone point down at the bottom. You're skipping the 2 in the middle. You're going to the 2 down at the bottom that look like this, where it says expand. Okay? Go ahead, try it out, practice, see what you can come up with. Stamps.
You know what you have to do?
Wait, hold on.
The power property says that if we have a P on the X of power, then we're going to have, so right here when we had 2Q, we said 3 times log 2. So here, whenever we have a little number approach to 65, we're always going to get back to 5 log X. So now I have ln of X squared, we're going to do okay? These two. Dolly, do you have your sheet? Good. Cool. Now just keep going. So for this one, you could break 6 into. Yeah, so the next one. Okay. This one you can bring in front, and this one you can bring in front.
I did. Because I
For this one, this is kind of like the
it.
12, where we rewrote it as 3 times 4. You can break that. Good. Okay. Let's take a look at this. So, this 13 is not one of these numbers. Like, the 13 is not like these. The 13 is like on this log right here. We really have a little basic 10. But since it's our common log, it doesn't show up. Or here, like, we really have a little basic E. But we just can't see it because it's the natural log. So in this one, this 13 is just your little base that's going to show up on all of your logs. Okay? So all of them are going to be log base 13. So right here, let's think though, because where did your, I see your 6 right here, but your 6 is separate from the A cube, right? Like all these things are being multiplied, they're all different. So this 6 is going to be the first piece, kind of like our 12, right? And then we add x to the 5th,
Yeah.
and your next piece is A
Yeah, because this log base
cubed.
13 is all.
Let's keep adding. Log 13 of, what's the next piece? B plus last piece log 13 of C to the 4th. Okay, cool. And then now start thinking if you can move powers out front, see if like this 12 you change it to 3 times 4, you can rewrite it to 6 and so on and comment. Oh yeah, you. Go ahead. Oh, you want me to check it? Your question? Okay. Okay. Notice here this little 13 is the same thing I was talking to you about. Is your base. Here technically you have a base of 10. But whenever it's 10, we drop it, we don't write it. But like all of these, technically you could write like a little 10.
Yeah.
And it needs to be on it. Okay?
I don't know about
So
the
it's
rest
not
of
part
those.
of these numbers, it's your little base that goes on over there. So for this one, the 13 is just a little number down to the corner. And it should be on all of these like this, which means you actually the first one is log base 13 of 6. This log base 13 of 8 cubed, this log base 13 of 8 plus equal log base 13 of C to the 4th. Okay?
Yeah, he is.
But then what is that? Like think of it as like x plus x, 2x. You have 2 log 2s there. Right? So it's a big one. So I would take either. And I mean, yeah, I would take either. So it's the same. Either way you think about it. It's kind of like this. I don't think we're talking about this, but you could have also thought about this from the beginning as
I don't know, yeah, I kind of stopped after like the second round.
Because this is negative,
I mean, the exponents
and then
are fine. I didn't
division
know
is
what
the
to do
same
with the rest of
as
those numbers.
subtraction, and then you still would have ended up with these two. So no matter which way you look at it, as long as you're doing the correct rules, like we should get to the same answer essentially. Okay, lovely, keep going. So now, anything that has exponents, like this 3 and this 4, where can those go?
Oh, go in the front.
Okay, and then this 6 right here.
So like 3 log 13A
Yep.
plus. Would it be?
Then
Would you put this in the front also? Is it a single exponent? Or would it be?
it would be 1, and if you put a 1 in front, it's just like 1 times something, it's just, yeah, so.
You just put 13 4 log 13.
Yeah, but don't skip this one, like you need to rewrite it,
Okay.
right? Like you're trying to rewrite the whole thing, and don't forget the first one. Oh, bye Kevin. This one doesn't have anything. But I'm gonna look at it. And we just start from here. But yeah, you don't need, it should always be log base something of something, and you just have log 13 of nothing. So you don't need that one, okay? Cool. Okay, we're gonna bring it back.
I didn't take over.
Bring it back, I'll talk about any questions on the last one. Okay, y'all. Eyes up here, voices off so I can get you through everything we need in the last 3 minutes. First up, this one should have been log base 13 of 2 plus log base 13 of 3. Then we're on the bottom two problems, right? Yeah? You see them down at the bottom of your paper? Okay. Plus 3 log 13 of A plus log 13 of B plus 4 log 13 of C. Kennedy?
Does it matter if the 3 is before the 2?
Oh, gotcha. Here, like if you just had those that way, no. Because 3 times 2 and 2 times 3 both give you 6. So depending on which way you wrote 6, you'll have different, but those would be the same. So if you had log base 13 of 3 plus log base 13 of 2 plus the rest of the stuff, you're fine. Okay? Make sure right now, looking at your logs, that all of your logs still have the little base of 13. That shouldn't have been dropped on any of them, right? The base should be the same on all of them. Okay, for this next one, I'm going to talk through a few steps with it. We have ln of 3y plus 2 minus the ln of 4 and minus the ln of the cube root of y, because you're dividing by both of these things. And then, if you rewrite this as 2 squared, you could get 2 ln of 2. And if you rewrite this as y to the what? Good. I'm skipping some steps for the sake of time since you already looked at it. But that should be our final answer, just showing you like one step in between. But I skipped over some things because y'all had a chance to already look at it. Okay? Giselle? Question?
Yeah, I didn't do the power property for like,
The last one?
yeah, for, you know how we put LS4 and two LS?
Bell hasn't rang.
Oh, I know what you're.
Okay, then I'm gonna go into one more thing. I can either do question or one more thing, but I'm gonna keep you all the way. Okay, so last preview for tomorrow, and then I'll answer Giselle's question with her one-on-one. Tomorrow we're going to go to what we call condensing. So if we just talked about expanding, which Melanie said is making these bigger, raise your hand if you can tell me what you think we're probably going to be doing if we condense something, Lirio.
Making it smaller.
Making it smaller. So notice, I'm starting with how many logs here? And I'm going to try to put them together into one log, like reversing what we did. Okay. Bye-bye. Yep.